welcome back. So, before the break we talk about the various sources of return that arise from investment in a fixed income security in a bond. The first of course is the contractual coupon interest, the coupon payments that you get. The second is you may reinvest the coupons at a certain rate of interest, and that would give you income on account of reinvested coupons, the interest on reinvested coupons. And then the third source is the capital gains or loss, which is the difference between the market price at which you exit the investment and the carrying value of the investment as per your books. I shall come back to the definition of carrying value and the example in at a later point in time. For the moment, let us restrict ourselves to what carrying value is. Carrying value is the amortized value of the security, that is the value of amortized value as it appears in the books, calculated at the YTM at which the instrument or the security was purchased. Then we talk about measures of yield. Nominal yield is the coupon rate, the contracted rate that you get on the investment in the bond or the fixed income security. Current yield, yield to maturity, holding period yield, annualized holding period yield, yield to call and yield to put if the bond has these additional option features. Now, as I mentioned, current yield is the annual coupon payments, the aggregate of the annual coupons divided by the current market price. But this is not a very useful or a very precise measure of yield, in the sense that it does not take any account of the reinvested income as well as of the capital gains or losses that may arise from the investment. Hence, it is seldomly used in practice. It is a layman's measure of yield, but it has serious pitfalls which restrict its accuracy and applicability. So, carrying yield is just about not the right measure of yield. Then we come to yield to maturity. The definition of yield to maturity I have already elucidated in an earlier point in time. Yield to maturity is the discount rate that equates the present value of future cash flows attributable to the security to its current market price. So, that is the definition, and the formula therefore is given at the bottom of the slide. Let us do an example to be more clear about what these definitions actually mean and how they are worked out in practice. Consider three bonds A, B and C. Consider three bonds A, B and C. Face value of each bond is 1000 units of money, whatever they may be, INR, dollars, and the maturity is 2 years. They have 2 years remaining to maturity, exactly 2 years remaining to maturity. We have three bonds A, B and C, each of face value 1000, and the maturity of each of the bonds is 2 years. Bond A is a zero coupon bond redeemable at face value. Bond A is a zero coupon bond redeemable at face value. Bond B is a par bond, that is, it is quoting at par in the market with annual coupons and par redemption. Redemption is at face value, its present quote is also at face value, and the annual coupons are paid on this particular bond. Please note the coupon rate is not given here. Bond C is an annuity with two equal payments at the end of the first and the second year, equal the total payments, total cash flows on account of an investment in bond C would be equal in the first year as well as this in the second year. In other words, both payments at the end of the first year and second year would comprise of coupons, interest as well as a certain amount of principal redemption. The annual spot rates are given as for the 1 year spot rate is 10% and the 2 year spot rate is 15%. We need to calculate the YTM of the three bonds. As far as the first bond is concerned, it is quite straightforward because it is a zero coupon bond. Therefore, the interest rate for the relevant maturity will be the YTM of the bond. The interest rate for a 2 year bond is 15%. So, the YTM of bond A is also 15%. So, this follows directly from the definition of YTM because it is a zero coupon bond. So, the interest rate that is relevant to this bond or the spot interest rate that is relevant to this particular bond's maturity, which is 2 years, it will be equal to the YTM. Hence, because the spot interest rate for 2 years is 15%, therefore, the YTM is also 15%. Now, we come to bond B. Now, bond B is a par bond, that means it is quoting at par, it is redeemable at par, that is also given to us, but the coupon rates are not given to us. However, the spot rates are given to us. So, let us work out the coupon rates first, or let us work out the coupon payments first. So, for that purpose, what we do is we equate the current market price. What is the current market price? The bond is a par bond, so the current market price is equal to its face value, which is 1000. So, the current market price is 1000, that is equal to x. What is x? X is the coupon payment at the end of the first year, divided by the discount rate, the spot rate, which is relevant for the first year, which is 10%, and then we have the second payment, the payment at the second end of the second year, which is the coupon payment, which is x, plus the redemption of principal, which is at par, and so that would be 1000 plus x, or x plus 1000. This would be the cash flow at the end of the second year, and this would be discounted at the 2-year spot rate, which is 15%. So, there should be a square here, I am sorry. So, x plus 1000 divided by 1.15 squared, because the discounting is for 2 years, and this gives us x is equal to 146.44. In other words, the coupon rate is how much? The coupon rate is 14.644%. Then of course, the second step is quite straightforward. Once we know the coupon rate, the working of the YTM is quite simple. The current market price is 1000, the payment or the cash flow at the end of the first year is 146.44, and the cash flow at the end of the second year is 1146.44, 1000 for the amount of principal and 146.44 for the amount of coupon. So, the total payment is 1146.44. Solving this quadratic equation, we can get y is equal to 14.64%. In fact, you do not really have to solve this quadratic equation, because it is a par bond. So, the coupon rate will be equal to YTM. We have already worked out the coupon rate, it is 14.644%, therefore, the YTM will also be 14.64%, but that can be verified by explicit calculation as well. Now, bond C is an annuity bond, that means it will make equal cash payments at the end of the first year and at the end of the second year, and it is quoting at par. So, the equation that we have to solve is 1000 is equal to A divided by 1.10 plus A divided by 1 plus 1.15 square. A divided by 1.10, because the spot rate for a 1-year payment is 10%, plus A divided by 1.15 square, because the spot rate for 2 years is 15% per annum, and this gives us A is equal to 600.516. So, this means that the annuity that we will get at the end of the first year is 600.516, which is also equal to the cash flow or the annuity that we will get at the end of the second year. Then we can solve the YTM equation. 1000 is equal to 600.516 divided by 1 plus y plus 600.516 divided by 1 plus y whole squared. I repeat, 1000 is equal to 600.516 divided by 1 plus y, this is for the first year, and 600.516 divided by 1 plus y at whole square, this is the discounting of the cash flow for the second year. Solving it for y as a quadratic, I get y is equal to 13.132%. This is the Excel working out of the same example, and we find here that the YTM of bond A, which is which are given in highlighted yellow highlighted figures, YTM of bond A is 15%, of bond B is 14.644%, and of bond C is 13.1324%. Now, there are some important observations. As the magnitude of the t equal to 1 cash flow increases, the YTM shifts towards the 1-year spot rate. Now, this is a very important observation, very interesting observation. Let us go back. You see, the first year cash flow, let us look at the relative magnitudes of cash flows. In the case of bond A, it is 0 and 1000. In the case of bond B, it is 146 and 1146. In the case of bond C, it is 600 and 600. And now we look at the YTM figures. Bond A, it is 15%, which is the spot rate for 2 years. Bond B, it is 14.64%, which is lesser than 15%. In other words, some movement towards the spot rate for 1 year, which is the lower spot rate of 10%, some movement towards the spot rate of first year is taken place from the previous bond, which has a cash flow only at the end of the second year. And then for the third bond, it has 13.13%, which shows that there is greater relationship, or the YTM is closer to the 1 year spot rate, as the 1 year or the relative interest payments or relative cash flows tilt towards or get skewed towards the 1 year rate. Greater is the proportion of cash flows in the first year, greater is the tilt towards to the first year of the YTM figure. Thus, the YTM depends on the relative distribution of cash flows. In other words, YTM depends not only on the magnitude of the cash flows as well as the timing of the cash flows. We will see that through explicit examples. We have two bonds here. This we are continuing with the same spectrum of spot rates. 1 year spot rate is 8%. 2 year spot rate is 12% and the coupon rates are 15%. We have got two bonds, bond A and bond B. The coupon rates on both the bonds are 15%, the spot rates are 8% and 12% for maturities of 1 year and 2 years respectively. Now, if we work out the YTMs, and let us look at the pattern of cash flows from the two bonds we are considering. Bond A is a level coupon bond. It gives you 150 with a face value of 1000. So, it gives you 150 at the end of the first year, and at the end of the second year it gives you 150 on account of coupon and is redeemed with the face value amount of 1000. So, the total is 1150. As far as bond B is concerned, the bond is redeemable in two equal installments. So, 500 amount of the principal will be paid at the end of the first year and 500 amount of the principal will be paid at the end of the second year. So, the total cash flow at the end of the first year will be 650, comprising of 500 on account of principal redemption and 150 on account of interest, and in the second year it will be 500 of principal redemption and only 75 on account of interest, because only 500 is remaining as outstanding on account of principal. So, interest would be paid on this 500 only. So, the net cash flows for bond A are 150 and 1150 respectively for first year and second year, and for the bond 2 it is 650 and 575 for the first year and second year respectively. And when we work out the YTMs, we find the YTMs to be 11.72% for the bond A and 10.42% for the bond B. So, it is quite clear that the pattern of cash flows determines the YTM of the instrument, or the YTM is dependent upon the pattern of cash flows of the instrument. And interestingly, higher is the cash flows in the second year, higher is the tilt of the YTM towards the second year spot rate, and higher is the cash flow for the first year, which is bond B. Higher is the tilt of the cash of the YTM towards the first year spot rate, which is 8%, which is again seen from the YTM figures. Now, YTM also depends on maturities. We have talked about YTM depending on the relative magnitudes of cash flows. YTM also depends on the maturities. So, now the bonds have a maturity of 5 years. Both the bonds A and B have maturity not of 2 years, but of 5 years, and the spot rates are 8% for 1 year and 12% for 5 years. And the interest payments are 150 at the end of the first year and then 150 at the end of the fifth year. So, there are only two interest payments, 150 at the end of the first year, 150 at the end of the fifth year. In the case of bond A, of course, the entire principal is redeemed in one go at the end of the fifth year. So, the total payment is 1150. In the case of bond B, the cash flow pattern is 650 at the end of the first year and 575 at the end of the fifth year. No intermediate cash flows in either case. So, in the case of bond B, redemption of 50% of the bond is at the end of the first year, and the redemption of the remaining 50% of the bond is at the end of the 5th year. So, we get 575 at the end of the 5th year and 650 at the end of the 1st year. And again, when we look at the YTM figures, we find that the YTM figures have changed from what the previous figures were 11.72% for bond A, now they have changed to 11.84%. Similarly, the YTM for bond A was 10.42%, it has changed to 10.93%. So, the message that I want to convey by reference to these two examples is that the YTM depends not only on the magnitude of cash flows, it also depends on the timing of cash flows. In other words, the YTM depends on both the magnitudes of the cash flows as well as the timing of the cash flows. In other words, it depends on the pattern of cash flows of the underlying instrument for which we are working out the YTM. Now, there is a question, why do we need YTM? That I try to address by reference to this particular example. Why YTM? What is the need for YTM? Suppose there are two bonds A and B, and we propose to hold the bond to maturity, and we want to select which of the two bonds A or B is better for us. I reiterate, our investment horizon is 2 years, that is up to the maturity of the two bonds. Both bonds have a maturity of 2 years, which is our investment horizon. Both bonds pay a coupon of 15%. So, now we need to decide which of the two bonds is better for us. Bond A, however, has redemption in one go at face value at the end of the 2nd year. Bond B has redemption in equal installments at the end of the 1st year and the 2nd year, 500 at the end of the 1st year, 500 at the end of the 2nd year. The spot rates are 8% for 1 year and 12% for 2 years. So, now our problem is to ascertain, to determine which of the two bonds is better for us. Now, based on this information, it becomes very difficult to take a call on which bond is better, whether bond A is better or bond B is better, because they are paying you the same coupon rate, they have the same maturity, although the actual cash flows is different, the pattern of cash flows is different because of a different redemption pattern. However, you will feel that even in the second case, because the bond is repaying back 500, so we can use that or the investment is reduced, and therefore, that is also justified, or that is also a reasonable choice. But we need a measure of yield, a measure of return, which gives us an unambiguous answer, or an unambiguous answer subject to, of course, the assumptions that we make. So, we shall come back to that, why I am qualifying this statement, there are reasons for this, we will come back to that. But for the moment, we need some kind of a justification, some kind of a measure, some kind of an approach which we could use, at least for a layman, to arrive at a decision on which instrument is better, and that is where the role of YTM comes into play. If we check the YTM of the two bonds, what we find is the YTM of bond A is 11.72%, the YTM of bond B is only 10.42%. So, on the basis of this, what we end up is, we feel that the bond A is better for investment than bond B. By the way, that is a message that the YTM can convey to us, but by the way, it is more interesting as a finance student to examine what is the reason, why is it that the YTM of bond A is higher than the YTM of bond B. The reason lies in the spectrum of spot rates. If you look at it, the 1 year spot rate is only 8%, the 2 year spot rate is 12%. Now, when we work out the YTM, as I will explain in detail very soon, when we work out the YTM, an implied assumption of the formula itself, which is by default, which is embedded in the calculation of YTM, is that the interest payments or the cash flows, intermediate cash flows, whatever they may be, whether on account of interest payments or redemption of principal, as in the case of the second instrument, whatever they may be, they are assumed to be, deemed to be reinvested at the YTM rate. And therefore, because the second year spot rate is higher, and therefore in the case of the first bond, what is happening is that the bond is not repaying back the principal, therefore, it is being reinvested. The principal which is not repaid, which is of 500 in the case of bond A, is being reinvested at 15%, which is the second year spot rate. However, when you look at bond B, because it is redeeming 500 or half of its payment in the first year, that means this 500 is going to be reinvested or is assumed to be reinvested, deemed to be reinvested at a rate which is YTM, which is lower than the spot rate. So, there lies the difference. In the case of bond B, the proceeds which are received on account of redemption of principal at the end of the first year are assumed to be reinvested at the YTM, which is lower than the spot rate for the 2-year period, and as a result of which we arrive at a lower return in the case of bond B, lower YTM in the case of bond B compared to the YTM of bond A. So, YTM and interpretation, a very important point, very important slide. Let us compare this formula right at the bottom of the slide. On the one hand, P0 is equal to summation of Ct divided 1 plus S0t. Now, I have mentioned a number of times and I reiterate once again that there is a functional relationship between the maturity date of the deposit and the rate of interest. The rate of interest is a function, is dependent upon the maturity of the instrument. You get different rates for different maturities. So, that is why I have used the expression S0t. The cash flow at time t, small t, is being discounted with respect to a rate which is relevant to that maturity and which has to be specified, because we cannot use one rate for the discounting of actual cash flows as per the real market. The actual market, it is empirically seen that the actual market gives you different rates for different maturities, and therefore, I need to apply a suffix to each rate which is being used for discounting the corresponding cash flow. C1 has to be discounted with respect to S01, C2 has to be discounted with respect to S02, Cn has to be discounted with respect to S0n, C capital T has to be discounted with respect to S0 capital T. But when you look at the YTM formula, there is nothing which is relating to the term structure of interest rates, or in other words, what I am trying to say is that when we work out the YTM, we use only a single number. In other words, let us repeat the definition of YTM. YTM is what? It is that single discount rate, please note this, at which the present value of all future cash flows equate its current market price. So, it is that one discount rate which, when applied over the entire life of the instrument, will give you the current market price. So, what I am trying to get at it now is that on the one side you have a spectrum of rates S01, S02, S03, S4, and on the other side, in the second part of the formula, you have a single rate. So, that means what? That means that single rate is in some sense representative of the entire spectrum of spot rates. In other words, it's in some sense, some rough sense, maybe not the conventional average, but it does in some sense capture the entire spectrum of spot rates which is relevant to discounting the cash flow pattern of a bond in one single number, and that is what is the YTM. That is the message, or that is the interpretation of YTM. So, YTM may be interpreted as some kind of average of the term structure of interest. So, it is that one single figure which captures the entire spectrum of spot rates. There is another interesting observation. The interesting observation is that the YTM will always invariably lie between S minimum, that is the lowest spot rate, and the highest spot rate. the YTM of any instrument of any pattern of cash flows will always lie between the lowest spot rate and the highest spot rate. So, again this property vindicates my contention that YTM is in some sense the averaging of the term structure of spot rates relevant to that particular instrument. So, this is the YTM of a 0 coupon bond. We have already discussed that. So, I will not devote time to this. For a case of par bonds, the formula simplifies because in the case of the par bond which is redeemable at face value, because the bond is quoting at par, the market price of the bond equals its face value. So, P0 is equal to F. This is on the one side, and on the second side, because the bond is quoting at par value and the bond is redeemable at face value and it is a level coupon bond. If we have all these assumptions embedded into our instrument, then C must be equal to Y, that is the coupon rate must be equal to the YTM. We have discussed that this also substituting C equal to Y in the two formula that we have in the first expression, F is which is equal to P0 is equal to summation of the coupon payments for the life of the bond at the end of each year. We are using annualized for the simplicity of exposition, for the tractability of the exposition, plus the redemption plus the discounting of the face value, which is the redemption value as well. So, this gives us the first part of the equation, and the definition of YTM gives us the second part of the equation. We substitute C equal to Y because the bond is a par bond, it is quoted at par, it is a level coupon bond. So, C must be equal to Y. We substitute C equal to Y in the whole expression and we do some algebraic simplification, and we end up with the calculation for the yield to maturity. Y is equal to 1 minus 1 upon 1 plus S 0 capital T, where what is capital T? Capital T is the maturity of the instrument, to the power capital T divided by the summation of 1 upon 1 plus S 0 T to the power small t. So, this is a simplified expression that we get for the case of par bonds, which are redeemable at par, which are trading at par. We can do some simplification in the exercise of calculating YTM. You see why this has been put here in the slide is that in the normal course of events, YTM is not easy to calculate. If you have n cash flows, or if you have capital T cash flows, you get a capital Tth order equation which will have T roots, and it is not necessary of course that all the roots may be real roots, but then the exercise of computing or solving that particular equation is quite challenging. You have to use numerical analysis for that purpose. There is no exact formula as of now. So, in this particular case, of course, you can simplify the situation radically. Now, a very important property of YTM. If you look at the formula for YTM, let us go back for a minute. This is the formula for the YTM. Let us talk about this one. If you go back to this formula of YTM, let us remove this for the moment. If you look at this formula for YTM, what we find is that what are the inputs needed for the YTM. Let us look at the inputs needed for the YTM. The inputs needed for the YTM are the pattern of cash flows, that is the magnitude and timing of the cash flows which are captured by the contract of issue, and in a sense they are singular to the bond that you are going to measure. In other words, they are removed from the market, they have nothing to do with the market. Market has no influence on the pattern of cash flows, that is the timing and the magnitude of the cash flows, because they are in the contract of issue. And on the left hand side you have the market price, which is again a figure that is known to you at t equal to 0. So, there is no randomness embedded in either of the two figures, and that means that the value of YTM that we calculate is also singular to that instrument. In other words, there is and furthermore, because the numerator here the CT figure, the cash flows are fixed by contract. So, there that immediately implies that there is a one-to-one relationship between the current market price and the YTM of the instrument. There is a one-to-one correspondence between the YTM and the market price of the instrument. In other words, I will go to the extent of saying, and which is indeed practically done, that instead of quoting bonds by their market prices, it is very often the practice to quote a bond by its YTM, because there is a knowing the YTM of a bond, knowing the pattern of its cash flows, I can easily work out the market price, and I not only that, I can unambiguously arrive at the market price. There will be no ambiguity about it, because there is a one-to-one relationship between the market price and the bond cash flows. So, given therefore, given a spectrum of, in other words, let us look at this relationship a little bit further. I have so far alluded to the one-to-one correspondence between the market price and the YTM. Now, the market price also can be worked out on the basis of the spectrum of spot rates, let alone the YTM. If I use the spectrum of spot rates, if I am given the spectrum of spot rates, I can also work out the market price. You can, let us go back to that formula. Look at this formula. Now, look at the first side. If you look at the first part of this formula, you can work out the price on the basis of the spectrum of market spot rates and the pattern of cash flows. Again, assuming that the pattern of cash flows are unambiguously defined in terms of the contract. If you know the spectrum of interest rates prevailing in the market, you can work out the market price again unambiguously. So, what does it mean? It means, and if you know the market price, you can work out the YTM unambiguously. So, that means what? That means given a spectrum of cash flows, given a spectrum of spot rates, we can unambiguously arrive at, or we can arrive at a value of YTM which is unambiguous, and this is another important feature. So, on the one hand, price and YTM have a one-to-one correspondence. On the second hand, the spectrum of spot rates also, given a spectrum of spot rates, we can also arrive at an unambiguous value of YTM for a given spectrum of contractual cash flows. So, we will continue from here, but the converse is not true. Remember, the converse is not true. In other words, if you are given the YTM of an instrument and you are given the pattern of cash flows, the timing and the magnitude of cash flows, you cannot work out the spectrum of spot rates unambiguously. So, given the YTM, you cannot work out the spectrum of cash flows, spectrum of interest rates, spectrum of market rates, but given the spectrum of market rates, you can work out the YTM provided you are given bonds cash flows. We will continue from here. Thank you.